Dr. S. Tamarai Selvi is working as a professor in the Department of Computer Technology, MIT campus of Anna University, Chennai. She has over 30 years of teaching experience. Grid computing, cloud computing, and e-learning are her areas of interest. She has successfully completed 12 research projects funded by Government of India and Tamil Nadu state government. She has established Center for Advanced Computing Research and Education and acquired 1 patent and has filed for 3 more patents in her research area. She has presented over 110 papers in international conferences and published 45 papers in international journals. She has authored 5 books. The latest book is titled Mastering Cloud Computing, published by Morgan Goffman Publishers 2013.
Welcome to UGC lecture series on computer science. We are discussing about the topic cloud computing, and in this episode we are discussing about the virtualization concept, and we are going to discuss about the different theorems suggested by Popek and Goldberg, and also what are the different types of virtualization we are having and what are the advantages. These are the things we are going to discuss in this episode. So, in the last episode we discussed about the theorem 1 of Popek and Goldberg, in which the condition for virtualization, in simple words we can say, if Si is subset of Pi, then ISA is virtualizable. If Si is not the subset of Pi, it is not virtualizable. Now, coming to the next part of it, why we are having this condition? To build a virtual machine monitor, it is sufficient that all instructions that could affect the correct functioning of the virtual machine monitor always trap and pass control to the VMM. That is what we have seen so far. It guarantees the resource control property, that is VMM is in the ring 0. Non-privileged instructions must be executed without VMM intervention. The holding of the equivalence property also follows. So, all the 3 conditions of equivalence, resource control, as well as the various effective or efficient control is also there. So, these 3 properties are covered by using this theorem 1. Then second theorem about this virtualization is as follows: a conventional third generation computer is recursively virtualizable if it is virtualizable, and a VMM without any timing dependencies can be constructed for it. So, what is the meaning of this one? Actually, first condition is it should be virtualizable. Second condition is the virtual machine monitor without any timing dependencies. That means, performance of the virtual machine monitor running on the real machine and under other virtual machine monitors will be indistinguishable. Suppose if you are having the actual virtual machine created over the physical machine, and from the virtual machine you can create another virtual machine also. So, it is possible to have the nested version of the virtual machines, that is called recursively virtualizable. You can create one virtual machine over the physical machine. Over that virtual machine 1 you can create another virtual machine. So, like that it can be nested. The capacity of the system is the maximum limit. So, for that condition, first of all the particular machine should be virtualizable, then VMM should have the same performance under the VMM as well as the physical machine. So, this is the second theorem here suggested. So, the resource bound limits the depth of the nested VMMs or the recursion. So, these 2 theorems are very much important to understand the concept of virtualization. So, in general, how to explain the VMM implementation? You are having the physical hardware, over that you are having the host OS. By using the VMM, it is possible to create the virtual machine in which you are having the guest OS, and above that you can have the guest applications, and the physical machines will be having its own applications. These applications are over the physical machines. Now, what are the different types of virtual machines? See, you can have the types based on the interfaces. First one is system interface, another one is the process based interface. The system interface means here you are having the ABI, application binary interface, as we have discussed in the previous episode. We are having efficient execution and you can add any OS independent services also. So, we are having the virtualizing software. Once if it is added, it is possible to extend the services of the OS also for the purpose of migration and intrusion detection also. So, you are having this ABI interface, which is just separating the virtual machine from OS and applications. As we have seen, you will be having the hardware, OS and applications. So, the virtual machine is considered to be the hardware, OS and applications. So, this is known as that ABI separation. Second one is based on the process. Here it provides the API interface and it is having the easier installation also, and it leverages the OS services and the execution overhead is also there. So, if you consider the OS, above the OS you are having the virtualizing software, then this is the actual virtual machine and you are having the virtualization process above this. So, the API interface is the actual separation of this virtual machine. In the previous case ABI, here it is API. So, based on the actual separation by using the interfaces, we can call it as system virtual machine or process virtual machine. Second one is system level design approaches. One is full virtualization, another one is para virtualization. See, whenever you consider the full virtualization, you can have the direct execution. Here this is the actual virtual machine created. This virtual machine monitor is placed over the physical machine. The virtual machine is knowing about the actual physical hardware and it can execute all those things. That is why exact hardware exposed to the OS, guest OS itself, it is efficient in execution and OS runs unchanged. That is the main difference. Full virtualization means the OS is not getting modified, the physical machine's OS is not getting modified. It requires the virtualizable architecture, as we have seen according to the theorem 1 of Popek and Goldberg. The example is VMware. Then para virtualization. Whenever you consider the para virtualization, the OS gets modified to execute the actual machine under the VMM. So, the virtual machine monitor is only interpreting all the instructions. So, the hardware abstraction layer is simply contacting the VMM. So, VMM is having the total control and there is no exact exposure of the OS to this one. That is the meaning of it. It is always depending on the VMM to have the interpretation. So, you are having this as the para virtualization. What happens is, whenever you install the virtual machine monitor over this host OS, that host OS is getting modified. Then only it is possible to expose the entire instructions by the VM to the physical hardware. So, that is the difference. Actually, when you consider the para virtualization, the performance is near native performance. That is what people are claiming, because the OS is getting modified. Whereas, here this is contacting VMM, in turn VMM will also interpret those things. So, you are having the different advantages as well as disadvantages in case of full virtualization and para virtualization. Now, we are having different examples for full as well as para virtualization. Now, let us discuss about the other types of virtualization. When you consider the virtualization, we are having hardware virtualization, software virtualization. Of course, the different types of virtualization will be explained under different categories. Just to explain the different types of classification, we have considered based on the interfaces and also by having the system level design, how it is divided or categorized, and also you can have hardware virtualization, means you are trying to virtualize the hardware. Some of the hardware vendors are providing the virtualization in the hardware itself. For example, you are having the P series of IBM system, where they are providing the virtualization in the hardware itself. So, you can create multiple machines in that hardware, that is called as hardware virtualization. Sometimes if the hardware virtualization is not provided in the system, then you can install some software and then you can create the virtual machines, that is called as software virtualization. Then other types of virtualization, you are having the memory virtualization, application virtualization, desktop virtualization, network virtualization, server virtualization, storage virtualization. It is essential to understand what is the meaning of each and every one. So, first let us consider the memory virtualization. See, we use the concept of virtual memory. Each application sees its own logical memory independent of the physical memory. Normally, we will be running multiple applications because we are having the processor capability more. So, the CPU speed is more. Instead of running a single application, it is possible to run 3 or 4 applications simultaneously. Internally, the processor is shared by different applications. Similarly, the memory can also be shared. Whenever the operation is executed, what happens? From the memory, the data is fetched and the CPU will get the data through the register and it performs the actual operation. When you want 8 GB of memory to run 5 applications, it is not necessary to have the 8 GB RAM size, you will be having only 2 GB. How it is done? Each application has its own logical memory, and even though the physical memory is lesser in size, we are getting the logical memory and we are able to execute the application. That is called as virtual memory. So, you will be having the physical memory, you are having different applications which is making use of part of the things, and the swap space, it is bringing the particular thing into the RAM whenever it is being executed. That is the concept. So, what are the benefits of the virtual memory? It removes the physical memory limits, it runs multiple applications at once. So, this is the concept of memory virtualization. Then we are having application virtualization. See, you can have the application virtualization by using the various concepts like JVM and CLR. Most of you would have worked in Java programming languages. Java is portable. That is what we claim. Why do we call it as portable? You can compile Java program in one machine and the compiled version of that program can also be executed in some other machine having different architecture, different operating system. How is it possible? There also we are actually having the abstraction of the underlying architecture. Suppose if you say the C language compiled in one architecture or in one operating system will not be able to execute in another machine which is having different operating system. Say you have compiled Turbo C, using the Turbo C compiler you have compiled a C program in Windows operating system. That compiled version cannot be executed in the Linux because the format generated by that one is different, it is suitable for Windows operating system. So, the Linux operating system may not be able to interrupt or interpret the meaning of the actual code generated by the C compiler. So, it is not portable, whereas whenever you have the Java program compiled in Windows machine and if you execute it in Linux machine, it will be possible to execute it. That is why how it is achieved? We call it as application virtualization. The program developed in one environment is actually executed in another environment, that is called application virtualization. For example, whenever you are having the Java, you compile it and it will generate bytecode. So, the process of compiling applications creates bytecode which is machine independent, and the code can be executed in any machine that provides the virtual machine execution environment. The only condition is JVM, Java virtual machine, that means the compiled code of Windows machine is executed on the JVM provided in the Linux machine. So, the JVM is the actual virtualizing software. So, you are having the Java virtual machine, so that the common platform is created using the JVM and the compiled version of the program Java program in any environment is executed in this JVM. So, you are having OS, above that you are having the JVM, and JVM is acting as the common platform for executing your program, whereas in case of C program we do not have such virtual machine. That is why we are not able to execute it. Another one is Common Language Runtime, CLR. CLR is also similar to JVM, it is Microsoft product. In .NET environment you are having CLR, so that they claim that it is inter-language platform. You can develop the different compiled versions of the different languages and that will run in the CLR, Common Language Runtime. So, that is also an application virtualization. They suggest these are the list of languages, programming languages supported by CLR. So, whenever you develop the application in one language, it can be run in CLR even though you are having different versions of different languages. So, these are all the examples of application virtualization. Next, desktop virtualization. See, desktop virtualization means you are able to just view the remote desktop. Remote desktop means you want to have the access to another virtual machine, and once if you are having the desktop virtualization, you are able to view the actual output in some other machine. See, in case of browser, you are trying to view some URLs. Actually, the server is available in some other location, you are getting the output displayed on your system. That is called as desktop virtualization. It is the ability to display a graphical desktop from one computer system to another computer system, and the examples are VNC, virtual network computing is one example, or remote desktop of Microsoft, or no machines, new X terminal server. These are all examples of the desktop virtualization, and it is more of remote display rather than the virtualization. See, this is an example, you are able to see the remote desktop in your own system. So, this is the example of remote display. We have another type of virtualization called desktop virtualization. Let us have a short break now. Welcome back after the break. Now, we are going to just discuss about different types of virtualization, and we have stopped with desktop virtualization. Now, coming to the next type of virtualization, which is called network virtualization. In case of network virtualization, we are trying to make use of various physical network accessories to be accessed as logical or virtual network accessories. Say for example, you are having various LANs, see VLAN A, B, C, then you are having different switches and routers which are useful for just forwarding the packets as well as the controlling of various packets to route through the required direction. See, when you consider the virtual network, each application sees its own logical network independent of the physical network. Here, suppose if you are having one switch, it is possible to create multiple switches using network virtualization. Say common network links with access control properties of the separate links are possible, and you can manage the logical networks instead of the physical networks, and we can have the virtual SAN, storage area networks, that provide similar benefits for storage area networks. Here we are calling it as virtual network. You are having a switch or router, and by having some network hypervisors, it is possible to create your own virtual switch, so that that switch will be controlling so many other nodes in the networking concept. So, we are having the network virtualization which is coming as part of the computing resources. We are having the facilities to create number of virtual networking accessories to implement the virtualization. Next one is the ability to refer to network resources logically leads to network virtualization, and it ranges over different levels from single machine to enterprise level, and also up to the virtual private network also it is possible to extend the virtualization. The hypervisors provide the utilities, the libraries to support network virtualization. Actually, we can have the virtual machine installed over the physical machine. Suppose if you are having 3 virtual machines created, it is possible to create a virtual switch to connect all the 3 virtual machines created out of the physical machine, and you can create the connectivity using the virtual switch. There is no need for physical switch to be used. So, that is called as network virtualization. Then the next one is server virtualization. Actually, you are having a big end servers nowadays due to the reduction of the cost of the processors memory. We are getting the high performance computing machines at lower cost. So, the servers are having the virtualization idea. Whenever you are having the physical servers before virtualization, you are having a single operating system image per machine, and you are having software and hardware tightly coupled, and it is possible to run multiple applications on the same machine, and it will create some conflict also. Sometimes if the applications are not utilizing the complete resources, it is an underutilized resource. That is why we are having the virtualization concept. In the server virtualization, it is possible to use the virtualization layer. Using the VMMs, it is possible to create number of virtual machines over the single physical machine. So, when you have the virtual machines created, the virtual machines break the dependencies between the operating system and hardware, and also it manages the operating systems as well as the applications as single unit by encapsulating them into virtual machines, and it provides strong fault and security isolations also. Totally it is hardware independent, all the machines are independent of the hardware. So, after virtualization, it is possible to reduce the underutilization of the resources. If it is possible to run 2 applications, you can create 2 virtual machines and you can run 2 different applications simultaneously. So, this is called as server virtualization. Then storage virtualization. The next resource is storage, that is, as we have considered memory, then CPU, that is the server virtualization we can consider. Then we have considered the network resources. Now, storage resources. Storage can also be virtualized. See, if you see the diagram, you are having heterogeneous physical storage devices available here. By having the virtualization layer, it is possible to have number of servers created, and all those servers will be having the access to the logical partitioning of the storage units. So, these are the storage units we are using, and that is called as storage virtualization. So, you are having the process of presenting a logical view of the storage, physical storage resources to the host, and logical storage appears and behaves as physical storage directly connected to the host also. The examples of storage virtualization are the host based volume management. It is possible to manage the total volume, and for that you are having the logical volume management, and using that it is possible to create the storage virtualization. And another one is that LUN creation, logic unit number creation. So, that is also another concept we are using. Then tape virtualization, you can have the tape available in some other location and it is accessed by another host also. So, the benefits of storage virtualizations are increased storage utilization, adding or deleting storage without affecting the application's availability, non-disruptive data migration. See, whenever you are having lot of data being created like big data and all, dynamically you can add some more devices so that it can be easily accessed by your physical machine. So, there are lot of advantages by having the storage virtualization also. Then what are the advantages we are having using virtual machines? Already we have discussed about the different issues or challenges faced by the industries. Now, we have discussed about the various conceptual ideas or principles and theorems used in virtualization. After having this fundamental concept, it will be easier to explain the advantages that are helpful to overcome the challenges of the various industries and other product development. The first one is freedom from upgrade. If a new OS version causes problems with the service, keep the old OS version for that service. It is possible. See, you can have the new version as well as old version. You can create one new virtual machine so that it is possible to have the new version also available here. You can easily upgrade it, and once the patch up and other compatibility issues are solved, then you can go for the new version. So, it will provide the flexibility for upgradation. Then the security, it reduces the potential number of users logging into the services. So, you can have the security by fixing these are the number of users that can be restricted, and you can have the undesirable sharing to be reduced. See, others unauthorized users cannot enter because each machine is isolated, and it narrows down the scope of attacks also. Of course, we are having some attacks for virtual machines also. There are a lot of papers coming up and research is going on to reduce this attacks also. See, whenever you are connected to the network, automatically security is the biggest issue that cannot be easily sorted out. People are trying to provide so many security measures over everything. So, the scope of attack is lesser compared to the physical thing. And development and testing, see, you are having the viable platform for developers, and you can have the quasi real environment also. It reduces the number of test machines. Instead of buying many machines for testing purpose, you can create the multiple virtual machines with different environment, one with Mac OS, one with Windows OS, one with Scientific Linux, one with Red Hat Linux, SUSE Linux. Like that, you can have the different versions and you test it in all the platforms, so that the testing will give the confidence of that application that can be executed in any machine. So, for that purpose we can use it. Then automated scripts for intensive testing, crash records, everything can be developed, and you can make use of it using these VMs. So, these are some of the important advantages. Then we are having snapshots and migration. This is also another advantage. Whenever you go for virtual machine, it is another boon, that is what we can say. The snapshot means it freezes a copy of the virtual machine. Whenever you are doing operations in your virtual machine, the entire set of virtual machine instance is actually having a mirror copy. Whenever you are having the various operations being performed, it identifies all the pages in the disk files and also the VM memory, and it uses the copy on write for any subsequent modifications. Periodically, once the modification is performed, again it is also updated, and to revert, the actual copy on write pages are thrown back to the actual thing. This snapshot is very much needed for migration. If you want to move a virtual machine to another host, it is possible without stopping the machine. That is the main advantage. The snapshot is helpful for simply keeping the mirror copy of the VM, and whenever you want to migrate it to some other system, it is very much helpful. Say during the night time, only a few machines are running, means all the few machines can be simply migrated to one physical machine and other machines can be shut down. Similarly, in case of any problem, you can also migrate the VM. So, migration is another important property. So, it takes a snapshot quickly and copy all pages of the snapshot and copy the modified pages also quickly, and it freezes the virtual machine and copy the VM memory. So, this is the actual advantage of the migration. So, for the migration we need the snapshot also. Then another advantage is cloning. The simple clone means you can freeze the virtual machine, copy all the files implementing it, and you can use the copy on write to speed up that process also. Cloning means just making a duplication. Then linked clone. Here you can take the snapshot, the original, and each clone is a copy on write version of the snapshot. So, in that way you can have the linked clone also. And we are having some hypervisors which are freely available as well as commercially available. So, the free versions are OpenVZ, VMware Server, Zen, KVM, VirtualBox. The commercial versions are the Virtuosa, VMware ESX edition, Zen Enterprise, and Microsoft Virtual Server and Virtual Ion also. So, these are the examples of hypervisors which are helpful for creating virtual machines. And to conclude, we have seen the different theorems as well as the basic ideas of virtualization concept, and also we have discussed about the different types of virtualization, and we have seen the advantages of virtualization. To revise this episode, the learners can just answer the following questions. What is the second theorem of virtualization suggested by Popek and Goldberg? Then what are the various types of virtualization we can have? What are the advantages of storage virtualization? What are the limitations of network virtualization? And what are the various applications you can have using virtualization? What is migration? What is cloning? So, if you revise all these questions, you will be able to understand the concept of virtualization, and you try to refer to some more hypervisors by downloading list of the hypervisors also. It is essential to know different hypervisors before going for implementing virtualization. So, with this we have concluded the fundamentals of the virtualization, which are very much needed to go for cloud computing. Thank you.